Alright, today we're going to talk about simplifying radical expressions. Here's our radical expression. We have 3 times the square root of 7 plus 5 times the square root of 1/7 minus 4 times the square root of 28. And the first thing I like to do when I'm doing these type of problems, I like to rewrite my problem, because what's going to happen, this problem can get kind of messy and then you won't even be able to figure out what the original problem is. So we can make sure we keep it clean. We're going to keep the original problem here. And then we're going to rewrite it. So the problem is 3 times the square root of 7 plus 5 times the square root of 1/7 minus 4 times the square root of 28. Immediately I see that I need to rewrite this term because we have a radical that's outside of a fraction. So whenever you have a fraction inside of a radical, you have to rewrite that expression or that term with the radical being applied to the numerator and the denominator. So that would be 5 times the square root of 1 over the square root of 7. This is pretty much clear cut, so we'll rewrite that as 3 times the square root of 7, and then we have 4 times the square root of 28. But we can rewrite this term because the factors of 28 are, 2 factors of 28 is 4 and 7. So the square root of 28 is actually the square root of 4 times the square root of 7. So we're going to break that up into the square root of 4 times the square root of 7, because 4 is a perfect square. So it's 4 times the square root of 4 times the square root of 7. Oops. Alright. So as we go to the next step, we're going to look at, still there's nothing to be done there, so we're going to look here. We see 5 times the square root of 1 over the square root of 7. The square root of 1 is 1, so really that's 5 times 1, which is 5. So we have 3 square root of 7 plus 5 over the square root of 7 minus, and that's 4 times the square root of 4 times the square root of 7. We know the square root of 4 is 2, so 4 times 2 is 8, so it's 8 times the square root of 7. So now, are we done? Not quite. It's still more that we can do. We notice that we have 3 square root of 7 plus 5 over the square root of 7 minus 8 times the square root of 7. What we really have are 3 fractions. We have 3 square root of 7 over 1 plus 5 over the square root of 7 minus 8 times the square root of 7 over 1. And anytime you're adding or subtracting fractions, the first thing you need to do is find out if the denominators are equal. When we look at these denominators, we see 1, we see square root of 7, and we see 1. Now, since those denominators are not the same and we need to add these together, we need to find the least common denominator. So the least common denominator of 1, square root of 7, and 1 is the square root of 7. So what we do is we have to multiply the square root of 7 times this 1 to get square root of 7. We already have square root of 7 here. And we have to multiply this 1 times the square root of 7 to get the denominator to be equal to square root of 7. And since we multiply the denominator here by the square root of 7, we need to multiply the numerator by the square root of 7. So that would be 3 times the square root of 7 times the square root of 7. This term already has square root of 7 in the denominator, so all we would simply do is just write that 5. And then we multiply this denominator, which is 1 times the square root of 7. So we need to multiply the numerator times the square root of 7. So that's 8 times the square root of 7 times the square root of 7. Now I did that for a reason. Because if you notice here, we got 3 times the square root of 7 times the square root of 7. So the square root of 7 times the square root of 7 is 7. So we would just combine that. We'll make that 7. So it'll be 3 times 7. 3 times 7 over the square root of 7. Plus, we just bring that down when nothing changed here. 5 over the square root of 7. And then we have minus 8 times the square root of 7 times the square root of 7, which is 8 times 7, which is 56 over the square root of 7. Now, 3 times 7 is 21, so 21 over the square root of 7. 21 over the square root of 7 plus 5 over the square root of 7 minus 56 over the square root of 7. Now, why would I multiply that out and do that? I mean, who knows? Minus 56 over the square root of 7. And now that we have all of the denominators equal, all we simply do is use these operations to determine what we do to the numerators, and then we keep the denominator the same. So we have 21 plus 5 minus 56 over the square root of 7. 21 plus 5 is 26. 26 minus 56 is minus 30, and all that's over 7. And there's your answer, minus 30 over the square root of 7. Now, what you could do to check your answer to make sure it's right, in your calculator you can do 3 times the square root of 7 plus 5 times the square root of 17 minus 4 times the square root of 28. And then whatever answer you get, you just take negative 30 and divide it by whatever the square root of 7 is and see if those answers are equal. So if you do that, you'll come out with about negative 11.34. And it really would depend on how many decimal places you took the square root, because we know that a square root of a number that's not a perfect square is an irrational number, so the number goes on and on and on and on and on. So however many decimal places you extend it out will determine how accurate that number is or how close those numbers are going to be.